Bismillah ar-Rahman ar-Rahim. Today I'm going to talk about the other investment criteria. In the previous week, I talked about the net present value and the equivalent annual cost. Before starting talking about this, it's important to address the weaknesses of the net present value. One of the important weaknesses in the net present value is not address the difference between the frame size. For instance, if we have two projects, the one project is with $100,000 and the initial investment in the second project is $50,000. So it is hard to compare between the one with $100,000 and the one with $50,000. So in this case, the financial analyst provide with other investment criteria, including the BI, profitability index, and the IRR, internal rate of return, the payback periods. So we will talk about these criteria. Okay, so the BI is similar to the net present value, but instead of discounted the cash flow, the initial cash flow, so this is the cash flow minus the initial cash flow, this is, okay, so this is the net present value. Instead of doing this, what we do is just the cash flow divided by the initial cash flow. And the discounted cash flow, I mean, divided by this is why it's called the profitability index. The importance of the profitability index, we can rank the projects. So it sorts out if we have two projects with different size, this with 100 and this is with 50. So the BI sort out this problem because we have the percentage of the dollar, the dollar return percentage, and this is the dollar return percentage. Let's see how we calculate the BI. The BI is calculated is the discounted cash flow, as you see here. This is similar to the net present value divided by the initial cash flow. Again, so this is the discounted cash flow divided by the initial cash flow. This is the little equation of. So this is cash flow is the discounted. So cash flow is coming in the first year divided or discounted by plus 1 plus k raised to the power 1 plus cash flow in the second year 1 plus k raised to the power 2 and cash flow coming in the n year divided by or discounted by divided by the initial cash flow. Okay? Yes. So this is profitability index. What exactly means the profitability index? What is the dollar return? Or in other words, what is the return? What is the rate? Thank you. What is the rate of return? Or what is the return of the initial investment? If we invest by $50,000, what is the return of the $50,000 as a percentage? Or if I invest $1, what is the return of the $1? 7%, for instance, 8%. So this is the idea of the profitability index. Okay? And the decision for the BI, the project with the higher BI is acceptable. And the project with the lower BI is not acceptable. And the threshold, the threshold of our decision, if BI is equal 1, it means we are on the edge. You know what it means, on the edge. Okay? If BI is greater than 1, we accept the project. If BI is less than 1, we reject the project. Okay? Yes. When the BI is equal 1, it means the net present value is equal. Yes?
The same.
Is equal. If the BI is equal 1, so the net present value is equal 0. Yes? Yeah? Is equal 0. So be careful in the multiple choice questions. Okay? So this is the decision criteria of the BI. If the BI is equal 1, we are on the edge. We are either accept or reject the project. It depends on the philosophy of the management. If BI is greater than 1, it means the cash inflows is greater than the initial cash. So then when we accept the project, if the BI is less than 1, it means the cash outflow or the initial cost of the investment is greater than the cash inflow. In this case, we reject the project. And again, the beauty of BI, we can compare between different projects with different size and with different lives. Okay? Be careful for the importance of the BI. BI is similar to the net present value, but the importance of it is address the weaknesses of the net present value. So we can apply we can drag between the different projects. Okay? So again, the BI is less than 1, the project should be rejected. If is less than 1, the net present value will be negative. Okay, we'll see this problem. Calculate the profitability index for project long. You know, project long, the previous one. The project long is expected to provide 5 years of cash inflows and to require an initial investment of $100,000. The discount rate that is appropriate for calculating the PI of project long is 17%. Is project long a good investment opportunity? Let's go back to the project long. Okay, let's go back to see. Is this project long? No? Yes, this one. A project long requires an initial investment of $100,000. I recommend you to use the streamline. It is important. So in the streamline, the initial cost is $100,000, okay? And is expected to produce the following cash flows over the next 5 years. We have 5 years. So we have 1, 2, 3, 4, and 5. And in year 1, we have 70,000, okay? In year 2, 30, 25, and 10,000. If we want to calculate the PI, it's very simple. PI is equal to the discounted cash inflows divided by the initial investments. So very simple, 70 divided 1 plus 0.17, the discount is raised to the power 1, 30, 1.17 raised to the power 2, 30, 1.17 raised to the power 3, plus 25, 1.17 raised to the power 4, and plus 10, 1.17 raised to the power 5, divided by $100,000. Okay? Just divided by $100,000. If the result is greater than 1, we will accept the project. If the result is less than 1, then the net present value is minus in minus. If the result is greater than 1, so the net present value is 1, because this is like the or looks like the net present value. Okay, try to do it. 1.18. 18. So 1.18, it means greater than, yes. What it means 1.18 from your perspective.
Return.
I know this return, it means. From financial perspectives or from the investment perspective.
For each dollar invested
Yes.
in this, I will return 1.8.
So we'll
You
accept.
get 18.
So we will accept the
18.
project.
Yes, you recover the $1 and you
get-
have extra 18.
Yes.
So is 18. So your return is 18. In addition to the $1. Okay? So this is each dollar invested in this project generates 18%. Okay? Any question? Okay, let's go back to the project, to the PI, and see the answer. Okay. Okay, so the answer is 1.18. And this is another example. P&G Pharmaceutical is considering an investment in a new automated materials handling system that is expected to reduce its drug manufacturing costs by eliminating much of the waste currently involved in its specialty drug division. The new system will require an initial investment of $50,000. So the initial investment here is $50,000. So we go back to the streamline, and our initial investment is $50,000. Okay? And is expected to provide cash savings over the next 6 years period as shown on the next slide. So we have 1, 2, 3, 4, 5, and 6. The cash flow is like this. So the initial investment is $50,000. So we have 15,000, 8, 10, 12, 14, and 16. Okay, so what is the PI? If considering that the K is 10%. K is the discounted rate. Okay, it's again very simple. And 15 divided 1 plus 10 raised to the power 1. 8,000, 1.10 raised to the power 2. 10, 1.10 raised to the power 3. Then 12, 1.10 raised to the power 4. Plus 14 raised to the power 10 raised to the power 5. And 16, 1.10 raised to the power 6, divided by the initial 50. Again, if the result is greater than 1, we accept the project. If less than 1, we reject the project. 1.07. So what it means, Fatima?
That means greater than $1.
Yes. So we accept this. Accept the project. From the financial perspective or investment, what it means?
Each $1
Yes.
generate 1.0.
7% return. Yeah, you are right. Generate 107, but from the investment perspective, if I invest $1, my return is 7%. Okay? It's fine. But if we compare this with the previous one, the previous one is more profitable than this one. Okay? Okay, go back to the question. So, this is another example if you would like to see. And the present value of OK. We'll see the other examples in the Now the internal rate of return, IRR. What it means, IRR, the internal rate of return. The IRR is when the initial cash flow is equal the cash inflow or the cash inflow. In other words, when the cash flow, the initial cash flow or the cash outflow is equal the cash inflow. Okay? I will ask myself, when the cash outflow is equal the cash inflow,
There is no proof.
or in other words, at what rate that the cash inflow is equal the cash outflow. Okay? So, from the mathematical perspective, this is the cash inflow. When it's equal the cash outflow, okay, so the cash, this is the cash in the first year, 1 plus k raised to the power 1, then cash flow for the second year, 1 plus k raised to the power 2, plus cash inflow for the n number of years plus k. I will ask myself, at what rate? So when I'm asking at what rate, I'm asking about at what k? At what rate that the cash inflows equal the initial cash flow. So we will try this in this rate, make the initial cash flow is equal the cash inflows. So the net present value in this case is equal 0. When I make the cash inflow is equal the cash outflow or the initial investment, in this case the net present value is equal 0. So the net present value, when the net present value make the cash flow minus the cash outflow, the cash inflow minus the cash outflow is equal 0, I'm looking for I, or internal rate of return. So how we answer this is a try and error. This is the answer. From the exam perspective, because you may waste your time in looking what is the best IRR, I will try to make them groups. Your answer should be between 15 and 20, for instance. So you don't need to look in 14 or to look in the 17 or in 25. Just focus your try and error between 15 and 20. Try to narrow down your focus. If I'm wearing your shoes, I will try the first thing 17. So 17 is in the middle. Okay? So if the net present value is greater than 17, you try something above 17. If 17 generate minus net present value, try to go down. Okay? Let's see how things going. Okay, just see the so the internal rate of return of investment is analogous to the yield to maturity of a bond defined in Chapter 9. We will talk this in Chapter 9 if we have time, but definitely we don't have time. So the net present value. The net present value is equal to the initial inflow, considering it takes minus or negative sign. So, and add to them the stream cash flow. So at the end you will have 0. Our question is, when IRR make the answer 0, is the internal rate of return. The decision is, if the IRR is greater than K, or the discounted rate, so we accept the project. If IRR is less than K, we reject the project. If IRR equal, we are on the edge. Yani we are sitting in here, on the edge, we are on the edge. We accept or reject, it's 50-50. Okay? Go back to the project long. For the project long, is expected to provide 5 years of cash inflows and to require an initial investment of $100,000. The required rate of return or discounted rate that is appropriate for valuing the cash flow of project is 17%. And considering 17% is the discounted cash flow is K. Now, what is the project long IRR? As it is a good investment opportunity. So what we can do this is a try and error. Because 17% is looking like indicator, is a hint. You could try things greater than 17 or less than 17 and to see. If you try IRR greater than 17, for instance, you try 18%, and you find that the 18% generates positive net present value, so it means you accept. Then the IRR is greater than the discount. Let's see. So, do you remember this cash stream? $100,000 is the initial investment, and the cash flow in year 1, 70,000, and in year 5 is 10,000. So what can I do then? The first is to try something. You could try by 18% and to see what is the result. Or you try 14% and then you see the result. Okay, see here. Yes, it's like try and error. Okay, before we demonstrate the solution methods, let's first take a look at the solution, which we will find to be 27%. Okay, discounted project cash flow for 1 year through 5, which is 27%. How we get the 27? Just by the try and error. This is using by Excel. In your exam, it's not like this.
You try and error in the exam.
It's like giving you hints how to answer this question. Okay, just hints. You don't need even to try and error. You don't even, for instance, if the net present value, if K is equal 17%. K is 17%. And it generates net present value by positive. What do you think IRR? Greater than 17%? Yes, definitely yes. You don't need even to do calculations. Okay? It's greater than. So the possibility of IRR, 1, is less than 17%, is equal 17%, is greater than 17%, no one, neither. So very simple, just go to the greater than.
Yes.
However, some students, they should think twice because they don't understand what is exactly the IRR means. Just in 1 second, it is greater than 17%. It doesn't need that much thinking on, okay? Yes. Again, train yourself now. If the net present value is equal 0, the net present value is equal 0, and K is 17%, what is IRR? What is IRR then? Look at you have less than 17%, you have equal 17%, you have equal.
Yes.
Equal, because if you apply 17%, net present value is equal 0, and this is the definition of the IRR. Okay, but the problem is, as I mentioned every time, the problem is, however, the beauty of the advantages of the IRR, it has some limitations. The limitations of IRR, it has sometimes more answers. For instance, if we have negative cash flows, so it generates more than one IRR. If I have 2 cash outflows, it means we will generate 2 IRRs. This is the problem of the IRR. See, for instance, this example here. If we have this $15,000, the initial investments, and in the year 1 we have 10,000, in year 2 we have 20,000, in year 3 we have minus 5,000. So we have 2 initial inflows, 2 initial investment, or let's say this is initial investment and this is cash outflow. So IRR in this case have 2 answers. Okay? So this is the weaknesses of IRR. Okay, because of these weaknesses, we cannot say hands off and stop. What is the solution? The solution by MIRR. Modified internal rate of return. What it means, modified internal rate of return, is to try to manipulate the cash streams. For instance, if you look at this example here, what we can do? What is the option? That to eliminate the impact of the negative cash flow. So what do you think?
بعمل اثنين.
Say it again.
من ال 50,000 لل 20 لنهاية
Yes.
السنة الثالثة
We want to eliminate the negative sign. Be careful.
بضيف 50.
Where? 50. Where? To this. Okay? Very simple.
يكون عندي 2 وآخذ مثلا متوسط.
No.
IRR.
So try to make your mind up.
نفس اللاين.
Try.
بزيد الأول.
Sorry?
بزيد من الأول بالبزنس.
By 5,000.
بضيفها على الأول بتصير 55.
You are right, but wrong. That's how it comes. It's half and half. You are right. The first word you said, okay, let's add the cash outflow to the first investment, the initial investments. Yes, right. But is wrong because you are not considering the time value of money. Okay, so how we can sort out this problem? Very simple. Don't fly at the moon, it's just in here. It's very simple here. This cash outflow is coming in the 3rd year. So what if I discounted this 1 plus k raised to the power 3 and back to the $50,000? Okay? So what I did here is just I discounted the $5,000 by the 1 plus k raised to the power 3 because it's coming in the 3rd year. So it is in here, we add up to the $50,000. So yes, you are right, but again, you have very little wrong. The little wrong is just we amend this by addressing the time value of money. Then, very simple, just add the 5,000, discounted 5,000 to the initial investment and then go back to answer the very normal IRR. Okay? So this is the problem. Complication with IRR, just 1 minute. Complication with IRR, unconventional cash flows, it means with negative signs. For a typical investment, initial outlay is followed by a period of cash inflows. In such cases, the net present value will always be positive if IRR generates than 1. However, this is the problem. if the cash flow pattern is reverse, is minus or negative, cash inflow followed by a series of cash outflows, as in the case of a loan, net present value greater than 0 indicate that the IRR is less than the discounted rate used to calculate the net present value. Net present value leads to the appropriate decision in both conventional and unconventional cash flow. So with negative sign, it's fine, it's work. Thus, it is prudent to use net present value while evaluating projects with unconventional cash flows. Although any project can have only one net present value. But the problem in the IRR will generate multiple IRRs. 1, 2, 3, more IRR. And you will see this is negative. So in this case, we will have more than one IRR. See, we have IRR at 10% and we have IRR at 20%. So what we can do, just make the, we will go back in next meeting about this point. We don't like to talk about it. Thank you very much. وإن شاء الله نشوفكم يعني الأربعاء القادم.